Let's talk about dot products. Dot product. Now, what is a dot product? The best way, uh, the best way to learn what a dot product is to visualize it first. So I'm going to draw two vectors. Oops. Hmm. This is vector A, and this is vector B, and this is the angle between the vectors. And keep in mind that these vectors could be any vectors. It doesn't have to be have to be in this direction or that direction. It's arbitrary. Is arbitrary the right word? I don't know. So the notation for the dot product is you take one vector, in this case vector A. Let's get more room. Vector A, and oops, forgot to write the dot. The dot is important. Dot dot vector B. This is the notation for a dot product. But what is it? What is it actually? Let's visualize it even further. Alright, so we got vector A is here, vector B is here. Let's, let's draw something different. Vector B is here, and the angle between them, theta. So what is the dot product? The dot product is essentially the component of one vector. What is the magnitude of the component of one vector in the direction of the other vector that it's dotted with? That might seem confusing, but let's visualize it. All right, let's pick this color. Why not? Draw a perpendicular line, and the what you get from the dot product is essentially this yellow vector multiplied by this pinkish reddish color. So it it's essentially B. This pinkish reddish color is the vector B. Or at least the magnitude of it is the magnitude of vector B times the magnitude of this yellow vector. Let's call that vector C for now. Let's call that vector C for now. And that would be equal to, oops, that would be equal to this thing over here. That would be equal to this thing over here. But what is vector C? What is vector C? Well, I assume you know some level of trigonometry, but this is a right triangle, right? And this angle right here is theta. Me Let me put the theta inside instead. So based on trigonometry, uh, the vector C, or at least the magnitude of vector C. Oh, let's let's put it in the color yellow. The magnitude of vector C is essentially, ooh, let's do it the long way. What what is let's pull out SOHCAHTOA. SOHCAHTOA. Now, what among these trigonometric functions can relate vector A to vector C? Well, so is sine opposite over hypotenuse the opposite side to the angle theta is the orange color the orange color, so that's not it. Tangent TOA opposite the orange again, the adjacent side, the yellow vector, otherwise known as vector C, also doesn't relate A to C. So we use cosine. So let's write that in blue. So cosine, zoom in, let's zoom in here. So cosine of the angle theta is equal to, again, adjacent. So we got the magnitude of vector C over the magnitude, oops, maybe that should be in yellow, the magnitude of vector C over the magnitude of vector A. Now this is the relationship between the vector C and vector A. So let's solve for C. So C, let's get yellow. The magnitude of C is equal to the magnitude of A, green, the magnitude of A times blue, cosine theta. We can plug this to here, and hmm, we'll get the magnitude of vector B times the magnitude of vector A times cosine theta. And that, my friends, is one of the many definitions of, are there many definitions of the dot product? Anyways, that's the definition of the dot product. Dot, let me rewrite it. So let's rewrite it in colorful colors. A dot B is equal to the magnitude of A times the magnitude of B, or vice versa, or you can switch it. That's what I meant. And let's pick yellow. Cosine theta. And that, my friends, is the definition of the dot product.